wasn't too many people that ended up coming in to the help session, I'm going to do a recorded help session for you. But I guess I can't do it on the actual whiteboard, so I'm going to try to actually do it over the worksheet and give you guys some explanations as it goes. So we'll see if everybody can see my screen in a second. Okay, so everyone should be able to see the screen. This is the worksheet that you should be able to download from Focus. Download it, save it on your computer as a file. You edit that file, that Word document, and then you just re-upload it in Focus. So the first ones are pretty simple. They're asking you, hey, what kind of function is this? Notice, this looks like the coronavirus graphs that we've been seeing on TV for ages. It starts off small and suddenly it grows really big. Which one of these is it? Is it a line? I don't think so. Is it an absolute function? That doesn't look like a V to me. Quadratic. It's definitely not a U-shaped graph. We didn't even talk about graphs for square roots, so I wonder what it could be. You highlight the one you want, or you can just click in the box. Then they want you to identify what type of line is this. Identify the line. Is it a line? Is it linear? Is it absolute value? Whatever. Same for this one. When we start to look at number two is all going to be about considering this graph. Look at some of the key points that we have on this graph. Okay. Notice these are your x-intercepts. These are your solutions. So when we did put this equation, the original equation, whatever it was, into the quadratic equation, or if we factored it, we got all the way down to the end and we ended up with x equals -1, 3. Those are our solutions. We can use these solutions if we need to work backwards to get the original equation. I'll show you that later. What else is important? Well, here's your vertex. That's the minimum value of this function because it's the lowest point. Hey, look right here. Here's your y-intercept. Okay, the point where this line crosses the y-axis. That's also C. We have to remember that a quadratic equation is always in this form. ax² plus bx plus c. Remember we said that c determines how wide or how skinny that u is going to be. The sign of c, whether it's a positive or a negative, that determines whether it's going to open up or if it's going to open down. So this clearly is a positive function because it opens up. So a is probably going to be a positive number. We don't know what that number is. We just know it's positive because it opens up. B determines if it's going to shift left or right. Okay, is it moving left? Is it moving right? We don't know. We have to figure that one out. And then you start to take a look at this. Well, what is C? C is your y-intercept. So at what number does this thing cross the y-axis? Oh, we just said that. We said it was right here. So C is right here. Is that a positive or negative number? How did we determine that? Because we know that C is an intercept. Since it's the intercept, if it intercepts at a negative number, then we know that C is going to be negative or positive. The harder part is if they want us to come up, what is the equation of this function? Well, we have to use the x-intercepts or your solutions. You have to use your solutions to figure out the equation. Okay, so what do? We have to set this up. X equals -1 and x equals 3. Remember what we did before? We have two separate equations here. We need to unsolve these, meaning we want these to be set equal to 0. So if this needs to be a 0, what do we have to do to move this over? What do we have to do to move this over? Okay, you'll notice that when you get to a certain thing, you're going to say, hey, I have a binomial. So an x plus or minus something equals 0. X plus or minus something equals 0. Well, think about this. If we move this over, what do we have to do? We had to add a 1 to both sides. So that's exactly what we have, is we have X plus 1 on this side. What do you have to do to move the positive 3 over? Okay. You're going to have two binomials. What do we do with two binomials? Box method them, and that'll get you your original equation. Okay? So this is all this. I'll see. Look, I did the work there. You guys can then start to look at this here. You'll notice they're asking you, well, what is the constant rate of change? This is the key part here. Rate of change. What is that? Slope. What is the slope of a linear function? Is it constant or is it not constant? What is the rate of change of an exponential function? Remember, exponential goes up sharply. Is that constant or not constant? Quadratics. We know that's a U-shaped graph. Is that a constant rate of change? I don't know. Here's a table. They'll want you to know, well, what is the slope between these 2 points, between these 2 points, between these 2 points, between these 2 points? What's the difference? Figure it out. And then the last one is, if this is a given table and it's following a pattern, clearly it is, what are your last two values going to be? I know you guys can figure this out and work on it. Do it. Find a way to turn it into me. I know some of you have had issues. I don't care what you do to get the worksheet to me. Screenshot it, email it to me, whatever. All right, just get it done. Have a good one.